Now we add additional pin at the output that is known either as preset or clear. Now how it works? See the basic circuit of the latch, that we know that this is a latch circuit that consists of two NAND gates with this as feedback like this, and this is known as QN, and this pin is known as QN bar. It means, suppose if we add a pin at this point that is named as preset, that is PR, here PR stands for preset, and what will happen if we either set PR is equals to 1 or 0. Assume that Qn initially is equals to 0. It means this will be as 1. Now we will draw its truth table, that when we write its truth table, that is PR preset and its Qn plus 1 term, then if PR is equals to 0, what will happen here? In this case we can say that if this is 0, then this will give 0 at this point and 1 at this point. It means this 0 is changing from 0 to 1. When 1 passes to this pin, this 1, it means this is 1 and this brings this one as 0, and this will again passes to 0. It means output is changing from 0 to 1. Now in all cases, whatever may be the value at this Qn, it changes to 1 when preset is equals to 1. What will happen if we set preset as 1? In that case, if we set this preset as 1 like this is 1, then what will happen? This 1 goes to this 1 and this is 1 1 1, it means this remains 0, and if this 0 comes here, then the output will be 1, and in that case if its previous output is 1, then this is 0. It means there will be no change at the output. It means this flip-flop will remain in its previous condition and work as a normal flip-flop. In this particular case, normal flip-flop. Now what will happen in this case if we add the additional pin at this NAND gate? Let us suppose this is N1 and this is N2 and this is N1, this is N2, and this is connected to this one Qn, and this is Qn bar, and like this, and no need to have this pin actually in this case. So, and we named it as clear. Okay, then in this case, in this particular case, if we write its truth table, then what will happen in this case? If Then if clear is equals to 0, then output will be 1 at this point, and if this is 1, then this goes to 0, and in each and every case the Qn is changing to 0. It means if this is 0, then output will be 0, and if it is 1, then अगर ये 1 आपके पास होती है क्लियर पिन, तो आपके पास आउटपुट में कोई चेंज नहीं आएगा. दैट इज Qn is equals to Qn plus 1 remain as Qn. Now see these two tables. If we combine this table with this table, or in other words we combine this circuit, this particular circuit with this circuit, then collectively we can design this as like this. Qn plus no needed, then this is this is this, and if we complete this circuit, complete the circuit of this flip-flop, then there are two inputs coming from this another NAND gates with clock pin CLK and with flip-flop D, where D is the final pin that is to be inverted and connected to the another NAND gate. Now the additional pins are connected in such a way that this pin is to be connected at used as preset, and this pin is to be connected as clear, CLR. So this forms a complete circuit diagram with flip-flop of the pins with preset and clear. Now what will happen if we collectively use them? Then in that case, if we see the outputs, then this is preset, this is clear, and this is your Qn plus 1. Then if preset and clear both are 0, then what will happen? In that case, the Qn and Qn plus 1, sorry, Qn and Qn bar becomes 1, and in that case your flip-flop will not work properly. We can say that this condition of input is not allowed. That is, if we are simultaneously using both the pins in the same circuit, then there is a condition that we have to avoid the input combination of 0 0 at both the pins at the same time. So if 0 is there at PR and 1 is there at CLR, then output will be 1. Now similarly, if there is a 1 at the PR and clear at the 0 value, then Qn will be changed to 0, and if both the pins are 1 1, then there will be no change in the output and your flip-flop will normally work as a T flip-flop. Okay, now see the changes here, that your output is set to 1 when preset is 0, and your output is 0 when clear is 0, okay, in this circuit, or from previous known circuit that there should be 1 at the preset when we want to reset the output, and there should be, sorry, there should be a, pardon, there should be 0 if we want to set q1 as 1, and there should be 0 at clear if we want to clear your pin, output pin qn as 0. So what will happen in this case, we have to apply the inverted output. So in this case we use another sign. In some textbooks and some references you will find a bubble at this position, that at this position like this. So this flip-flop will now change, and your truth table is now changed to the new truth table, that is like this. The truth table will now not work for preset and clear input as 1 1, means one, there should not be both the pins as 1 at the same time. It means qn plus 1 must be avoided, or you can say that avoid both the pins at the as a 1 at the input. Now what will happen, if preset is equals to 1 and clear is equals to 0, then your output is set to 1, and if preset is equals to 0 and output is clear is equals to 1, then output will be 0, and if both the inputs are 0, then it will work as a normal flip-flop, and now we can use it as a D flip-flop. Thank you.